Hello dear students, let's recall what we studied in this chapter. First one we studied about charge. What was the equation for charge? Q equal to NE. What is the unit of charge? Coulomb, isn't it? So let's write that equation here. Q equal to NE. That was the first equation we studied in this chapter. Then we come to the electric current. That is the flow, ordered flow of electric charges are called electric current, or the flow of current per unit time I equal to Q by T. And from this equation we made an equation for Q. Q equal to I into T, isn't it? So we made equation Q equal to I into T. How we made this equation? Taking this T to the other side, by T will become into T. I into T equal to Q only here. That is Q equal to IT. The next thing about potential difference, isn't it? Potential difference was defined as the work done in bringing a unit charge from one place to another. That is potential difference V equal to W by Q. That was one equation. Then another equation for V, from Ohm's law we got V equal to IR. These was the equations related to Ohm's law, up to the Ohm's law, from electric charges up to Ohm's law. And after that we studied equation for this resistivity R equal to rho L by A, where rho indicates resistivity. Unit of resistance is ohm, unit of resistivity is ohm meter. Okay, fine. What is the unit of electric current? Ampere. Unit of time, second. Unit of potential difference is volt. Unit of work done is joule. Unit of Q, that is Coulomb charge. That much only. Then we studied about the combination of resistors, parallel and series combinations. So just we discussed that matters yesterday, so I am not repeating that equations here. Now we have another topic, electric energy. What is electric energy? So when we are considering any electric circuit, when the current is flowing through that electric circuit, it faces some resistance from objects present inside the conductors. Even if it is a good conductor, let it be gold or silver, they are good conductors. Even if it is good conductors also, there are certain elements which resist the flow of electrons through them. These are called the things which resist the flow of electron. This property is called resistors or resistance. Property is called resistance and the device is called resistor. So it faces a resistance while flowing the current through an electric circuit. So a current has to done, the current has to do some work, or the current has done some work in order to maintain a good flow of charges through it. What is that? Electric current has to do some work in order to maintain a flow of charges through them in an electric circuit. So this work done is stored as the electric energy. So what is electric energy? The current in a circuit has to do some work in order to maintain flow of charges through it. This work done is stored as the electric energy inside that conductor. We already know the equation for electric energy, W equal to V into Q. From these equations we can form an equation for work done. Work done is equal to V into Q. V into Q. How it becomes V into Q? Taking Q to the other side. So it becomes W equal to V into Q. So same equation we are studying here too. So nothing new you are studying. Just the things we already studied. W equal to V into Q. Now we can substitute another value for Q. We know there is an equation Q equal to I into T. Substituting Q equal to I into T, we got V into, instead of Q, we are substituting I into T. I T. IT. So it becomes V I T. So this is the first equation. From W equal to V into Q, we got equation VIT. Now we are going to substitute for V. We know V is equal to IR. Let's substitute the value of V in this equation. So instead of V, we are substituting IR. So instead of V, we substitute IR. So it becomes IR into I into T. What is I into I? I square, right? I square RT. So the equation becomes I square RT. So that is the second equation for work done or the electric energy stored inside the conductor. W equal to I square RT. Now we are substituting another value for I. So we will get one more equations. See, from this equation, from Ohm's law, we can write I is equal to, we can take this R to the other side. It is into R. When we are taking this R to the other side, it becomes V by R. I equal to V by R. Isn't it? We are taking this R to the other side. So I become alone here. It becomes I is equal to V by R. Now we are substituting this value of I here. It is I square. So what will be I square? V square by R square. See, I is equal to V by R. For I square equal to V square by R square. So V square by R square into R into T. We have R square, here R. What is R square? R into R. So we can cancel one R. So the remaining terms are V square by R into T. W is equal to V square by R into T. So this is the third equation. So we get three equations. We can write it here. Start these equations. First one, we start from V is equal to W is equal to V into Q. Then we reach at V I T. Then W is equal to, we substitute another value for V equal to IR. Therefore it becomes I square RT. That is the second equation. And from the equation I equal to V by R, I square equal to V square by R square. Cancelling R, we get V square by R into T. 1, 2, 3. Here we have three important equations for electric energy. What is electric energy? Some work has to be done in order to maintain a flow of charges in an electric circuit. This work done is stored as the electric energy inside the conductor. So if potential difference, current and time is given, we can find electric energy. Or if only current, resistance and time is given, then also we can find electric energy by using the equation I square RT. Sometimes potential difference will not be given. So at that time we can use this equation. If potential difference and resistance only given, I is not given. Here we have I is not given. So at that time you can use the third equation V square by R into T. There is no I here. So different time you can use different equations and you can find the answer for electric energy stored inside a conductor. Hope it is clear. Very easy topic. Thank you.